All right, 7 square root of 8. So this I switched up a little bit from last week. I have a number in the front now, but we're going to ignore that for the moment. And we're just going to work on the 8 part. So 8 is 4 and 2. And 4 is 2 and 2. Okay, so I have 3 2s. I'm going to circle 1, 2, and cancel 1. And this 2 is just left over here because you're looking for pairs. So when you have a number in front, that stays in the front and multiplies with any circled numbers. So 7 will multiply by the 2. And then any leftovers stay inside and multiply. And final answer is 14 root 2. Okay, now flip to the back, please. Number 11. Okay, so this week we're going to start taking what we did last week, factoring, and taking it one more step to solving. Notice these have an equals 0 in them, or there's an equation in them. So that means we need to actually do more than we did last week and solve. So we're going to do factor and then zero product property. We're going to start with the factoring. And what goes in the first box, guys? N squared, gorgeous, beautiful job. What goes in the last box? 3. What goes on the top of the diamond? You're on fire. It's awesome. Bottom of the diamond, or Ed. This is one of those pesky ones where you have to remember the times 1 thing. So this would be 3n and 1n. And you don't have to put the 1. You can just put 3n and n if you like. It's a little more sophisticated. I like to put the 1 for anybody who needs it. 3n, 1n. Okay, now I do greatest common factor of these two is n plus 3, n plus 1. Okay, so this is sort of where we left it last week. We left it with the parentheses. We did not have the equals 0. And now we're going to do the thing called zero product property. Zero product property means that each one of those things can be equal to 0. So we take this part and this part, and we equal them to 0 separately. This step I'm going to show on this, but I'm never probably going to show it again. Okay, and now I have solved the equation by factoring and then using zero product property. And if I said that in extremely unacademic language, I would say diamond and box and then equal them to 0. All right, guys, flip to the domain and range page when you're ready. All right. This one's a little different. It's just dots. You guys know what vocab word that is? It's labeled up above on your paper. What do we call it when it's just dots? You're not wrong. Discrete. It's called discrete. Okay, so I labeled the x-axis. Let's figure out all the places that we have x's. So here, 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 and here. I'm noting it on the x-axis specifically. Here, 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 and here. It's just separate numbers. So I'm going to say x equals -3, -2, 1, 2, and 5. Okay, range is similar. There's one here, one here. There's two here, and one here. R equals -5, 0. So there's two dots that have a range of 1, but we're just going to write the 1 once. Don't repeat values for domain and range. And then 4. Okay, is it a function? So are any of the dots like directly above each other? No, it is a function. It passes the vertical line test. I drew vertical lines through all the dots and I didn't hit 2. And this one is called discrete. Okay, last one. I really like this one, number 6. This should remind you of your poster. This is a square root function right here. You guys remember doing your poster, it was super fun. Okay, and it had this like x is less than or equal to type, domain, and range. Anyway, so here's x. And I noticed that it goes forever this way all up to here. Okay, so x is less than or equal to 4. Notice I sort of cheated. You see my arrow here on the x-axis? I made sure that my inequality arrow pointed the same direction. Also, if you're not sure which one is greater than and which one is less than, you can always look up at my handy crocodiles. Will help you all year up there with that. Okay, range. So it looks like it's going up forever. It's going up slowly, but it's going to go up forever. And it's all of this, and then the bottom of the graph seems to be right here. Y is greater than or equal to 0. Is it a function? Yes. You guys probably already knew that. And it is continuous. Continuous means that I can draw it without picking up my pencil anywhere. All right. I think you guys are done with this packet for today, so you can put that away. We're doing 2 problems out of the book, number 29. And number 29, so you know how we looked at the square root functions, and it was probably your first time ever graphing a square root function. So now we're going to look at 1 over x. What does 1 over x type of function look like? And for 29, we're going to do one together. For number 30, I'm going to have you do one that has to do with your table group number. And then we're going to do notes on quadratic equations, which was just the thing we did for number 11 in the warm-ups. We're actually going to do it 2 ways, but then you're going to save me a spot in your notebook because later we're going to come back and complete the square. So usually there's 4 different ways to solve quadratic. One is factoring, diamond and buff. 2 is quad formula, which we're going to do today. 3 is by square rooting both sides. And I don't even like to touch that one really because people use it illegally all the time. I'm not going to talk about that for the moment. And then 4 is complete the square. We actually do notes on completing the square in chapter 2. So I don't know why, but that sort of gets held on to chapter 2. But we're going to leave a spot in our notebook to come back and put this. And then your homework is 35 through 38 and 41. So what columns is that? 35, 36, 37, 38, and then skip to 41. Okay, now this is my joke for today. This is a teaching joke. That's Gandalf. Do you guys know who Gandalf is? Yeah. Okay, so there's this scene where he like jams this like scepter thing in the ground and says you shall not pass. But anyway, for us, this is what the graph of 1 over x is going to look like when we get there to number 29. And this is called an asymptote. You used asymptotes in Math 1 when you did the like exponentials and it like shot up. It was like the bunnies multiplying thing. And you represented it with a dashed line. These are going to have 2 asymptotes. And it's been like a hot minute since you've actually like done any of that. So I'm going to pretend that you haven't done it at all. But asymptote is a fun word to say. I mean, if nothing else. Okay. When you guys are done setting up your notebook for number 29, make sure that you have a graphing calculator. Hey everybody, so today we're going to investigate function 1 over x. I picked a very specific one, 1 over x, and I added the plus 7 in there to make it interesting. We can look at the plain 1 over x and see what the difference is between that and 1 over x plus 7. But before I start, you guys remember how we were doing our posters and you guys are going to go to make your table and you froze up for a second because like, I don't know where to start the table. Remember that moment? Okay. I put -7 in the table first on purpose without anything else because that is a very special number in this particular problem. Do you guys see that if I put -7 in the x spot, I would get 1 over 0, which is undefined. Okay, that's that dashed line that Gandalf is standing at. You can't have a value there. That's what makes that asymptote. let's see how that looks on the graphing calculator. But first, I need you to know that I sort of made you do too much work last week. So if you guys could get your graphing calculator out, and don't be mad. Don't be mad. Get your graphing calculator out. Turn it on. And then I need you to go up to this y equals button here. So it's the very top left button, y equals. Now, really quick, mine is going to be a problem, I can tell already, because I have apparently been doing statistics and math at the same time. You guys see how I have plot 1 and plot 2 highlighted? Okay, you need to make sure that you do not have those highlighted. How do you fix that? You scroll up with the arrow key, and then you hit enter to turn it off, and then scroll over and hit enter to turn it off. Everyone should have plot 1, 2, and 3 not highlighted. There should not be any plots highlighted. Otherwise, you're going to get an error when you try to do it. Okay, now try not to be angry because I do things for a reason, I promise. Just watch me for a second. I'm going to go back to number 13 here, and I'm going to type 3 square root x plus 5. Don't do this, please. This is not for you to do right now. I'm just demoing number 13. I made you do this by hand, did I not? Like plugging them in each separately. Okay, but the graphing calculator will actually make the table for you in about half a second. Oh, Mrs. Talbot, how could you make us do all that math? Well, I did that because you're not always going to have a graphing calculator. So I want you to be able to like plug things in to make a table. Okay, but now we're going to use this to our advantage today. Okay, so this is what I want you guys to do. Hit this y equals button. If there's anything in there, hit the clear button. The clear button is underneath here. So clear this. It should look just like that. And then we're going to type 1 divided by, and then this is very, very specific, parenthesis, x plus 7, parenthesis. Your calculator follows order of operations, and if you don't put the parentheses in there, it's going to mess it up. So over here in your notes, plus 7, yeah. I'm going to write calculator notation up here. Parentheses, parentheses, parentheses. Okay, we're going to learn to do 2 things today with typing a function into the graphing calculator. We're going to learn how to graph it, and we're going to learn how to make the table. The table is the most useful thing for you anyway, as far as a time saver. So do you see how the word table is right above graph in blue here? You guys see it? Okay, go second graph and get your table. But I need you to scroll so that -7 is kind of in the middle of your screen, like -7 is in the middle of my table. Does anybody need me to demo that again? Okay, so you're here. Are we here? Okay. Okay, go second graph. And then scroll using the keypad so that -7 is kind of in the middle-ish. Are you with me? Okay, now we're just gonna cheat off of the graphing calculator here. So yes. Because did you not have an error? Hold on that thought. You do? Okay. You should notice some symmetry here between your coordinate points. If you guys are doing homework at home, no graphing calculator, go to Desmos. Desmos, you can click on that little gear thing, it'll make the table for you and everything. You can actually just click along it to get the thing. Okay, we need to do two more things before we're actually three more things before we're done with this problem. First, we need to connect the dots. We need to figure out where asymptotes are. So there are actually two asymptotes on this graph. We need to figure out where those are, and then we're going to do some describing. Okay, so in order to sketch the graph, after I get my dots, I'm going to go back to the graphing calculator and hit the graph button, but I'm going to actually have to fix my window. Hold on. Zoom 6. And that is how your graph should look. However, before we sketch it in, it's really best to draw the asymptotes first. So the first place we're going to draw an asymptote is where I had this error at -7. So I'm going to come along here, just like Gandalf had, and make a dashed line. At -7. Then I'm going to come along the x-axis, and I notice there's another place where my graph is approaching at 0. So I have a vertical line at -7 and a horizontal line at 0. I'm going to label the equations for those. X equals -7, y equals 0. Okay, and then that kind of gives me boundary points to draw my curve in. Make sure that your curve, you do the best job to not touch the asymptotes. Remember, Gandalf says, you shall not pass. That doesn't mean for this class. My other joke of the day. You're hilarious, Mr. Tyler. Yeah. Okay, we have 60 more seconds of this problem. Okay. Okay, this is called a rational function. Rational meaning ratio. So it's a fraction where x is in the bottom. It does not have to be x plus 7. It can be anything in the bottom. You guys will see when you do your table number. But the shape has a cool name. The shape is called a hyperbola. I know you've heard of a parabola before. Parabola looks like this. Hyperbola looks like two boobies. Do you guys notice how the hyperbola kind of exists in the top right and bottom left? Okay. I love the domain and range for these. They're my favorite. The domain is all reals except x can't be -7. Why not? Because I got this dashed line here that it can't cross. Why not? Because you can't divide by 0. And this guy is discontinuous because I have to pick up my pencil to do the other part of the graph. Okay, number 29 is done. Any questions before we move on? Okay. What I want you to do next is set up your notebook for this, except for that you're going to do this at the end of the period, but make sure that your notebook is set up. What does that say? Can you guys read it? Yeah. X minus table number. I would not write the words table number in there. I would put the number of your table number. So you guys here would not write X minus table number. You would write X minus 6. You guys would write X minus 2. You guys would write X minus 7. You're lucky because you got the opposite of the X plus 7. Okay. Real quick though, before we move on, what number should I put here in the middle of my table? Where should my table be centered on? Yes. Table number, beautiful. Okay, you're not doing this problem right now because you're just going to leave the space. We're going to do the two quadratic things, and then I'm going to let you finish this at the end. So you can have as much time as you need. Just set it up and then just leave it for now, just with saving space. All right, guys, hold that space. And then in a different spot, Notice these are the same problem. We're going to do the same problem two ways. Then we're going to leave some space to do it a third way from complete the square. Solve by factoring. First thing I need to do when I'm factoring is get it equal to 0. So minus 16 solve by factoring is very specific. I'm going to use diamond and box. X squared negative 16 negative 16x squared 6x. What is this? 8 and negative 2? Kind of lied and said I wasn't going to show that again, huh? Just for the notes. Okay, first thing I need to tell you, there's the plot formula. Some of you have a song going through your head as you write it. We're going to get the same answers as we did from factoring for quad formula. But you see how nice these answers are? Negative 8 and 2. This is a baby one. Usually their quad formula problems are much harder than this, where you have to like simplify the square root. You might have an I, you might have to reduce. But this particular one right here is a baby. That's okay. Doesn't mean anything bad. It just means that I need you to know this is not like full difficulty. First thing, get it equal to 0. And then assign A, B, and C from the leading coefficients in your problem. So A is the 1 from 1x squared, B is 6 from 6x, and C is negative 16. And then plug it in. Notice how I use parentheses in the calculator, just like I wrote it down. This one, as I said, is a baby one because the square root of 100 is nice. It's 10. So I broke it up into two pieces, -6 plus 10 over 2 and -6 minus 10 over 2. I got the same answers, 2 and -8. Okay, all I ask is that you write this and then just leave me some space, like the same amount of space that you left for quad formula for us to come back and do complete the square. And then for the rest of your period, work in your group to finish your number 30, where you fill in your graph table and describe for your table numbers hyperbola.